Okay, perfect. Now let's put all this together. Every offer in dMarket moves through a 7-state lifecycle, and each transition, a specific participant calls a specific circuits with a specific fund flows. This is the state machine. State 1, it's the new. The seller calls offer item with an item ID, a price, a metadata, and their own seller metadata. The circuit auto-registers the seller if they are new, generates a deterministic offer ID by hashing the seller ID, the item ID, and price, and inserts the offer into the ledger. All metadata is disclosed for marketplace discoverability. You need to go to see what's it's for sale. While the offer is new, carriers they can bid. Set carrier bid. Let any carrier propose a delivery fee and publish their RSA encryption public key. Bids are stored in a nested map. Offer ID maps the carrier ID maps to fee. Multiple carriers can bid on the same offer. Competition drives fees down. State 2. Purchased. The buyer calls purchase item. This is where it gets dense. The circuit validates the selected carrier's bid exists, checks that the deposit amount equals exactly price plus fee, not more, not less, and runs the coin through receive deposit into the escrow treasury, encrypts the delivery address to the carrier's public key via the witness, stores the purchase details, and deletes the carrier bids map for this offer. One transaction, identity obfuscation, deposit validation, address encryption, bid cleanup, all in a single CK proof. State 3. Picked up. The selected carrier calls item pickup. They deposit their matching collateral, price plus fee, again, into the escrow treasury, and optionally set a delivery expected time of arrival. The treasury now holds 2 times the quantity, price plus fee. State 4. In transit. The seller calls confirm item in transit to verify that the carrier physically picked up the item. This is a human verify step. The seller confirms handoff happened. While in transit, the carrier can call set offer Edda to update the delivery timestamp. Multiple updates allowed. The buyer can track progress. State 5. Delivered. The carrier calls delivered to declare physical delivery is complete. State 6. Completed. Happy path. The buyer calls confirm delivered. This triggers the escrow payout. Send payments sends price plus 2 times fee to the carrier. That's their deposit back plus the delivery fee. Then sends price to the seller. Treasury empties and transaction is done. But there is an alternate path. From delivered, the buyer can call dispute item instead, moving the offer to state 7, which is dispute. The seller then calls resolve dispute, which in the demo implementation refunds the buyer price plus 2 times the fee and burns the carrier's deposit equivalent. Note that in production, you would want more sophisticated dispute resolution, multi-sig arbitration, evidence submission, partial refunds. The demo keeps it simple to show the pattern. And now the 7 states. Clear permissions at every transition. Fund flows that guarantees everyone has incentive to behave, and every state change is a transition with a CK proof, verifying the caller's identity without revealing it. Let's be precise about what's private and what's not, because privacy claims without a boundary analysis are just marketing. What's disclosed? Public on the ledger. Offer metadata, items names, prices, descriptions, images. This has to be public because it's a marketplace. People need to see what's for sale. User obfuscated IDs are public too. They are map keys. But remember, those IDs are unlinkable to wallets and unlinkable across roles. Carrier encryption public keys and bit fees are public. Coin amounts are visible during transactions. You can see that someone deposited a specific amount. Offer state transitions and delivery ETAs are also public. So what's private? Meaning never leaves the circuit or the user's device. The secret key witness. The delivery address in plain text. Only the carrier can decrypt it. The mapping between wallet addresses and obfuscated IDs. You can see an ID exists, but you can't connect it to a wallet. The user's password and RSA private keys. And critically, you can tell if the same person is operating as a buyer, seller, and carrier on the same marketplace. The identities are mathematically separated. The disclosure boundary sits exactly where it should for commerce. The marketplace functions publicly. You can browse offers, see prices, track delivery status. But the identity layer stays private. You can't build a profile on any participant. You can't link purchases to people, and you can't find anyone's home address. This is rational privacy applied to commerce. Not everything is hidden. That would be kind of making the marketplace unusable. Not everything is public. That's what we already have, and it's privacy nightmare. Selective disclosure at exactly the boundary commerce requires. Let's put dMarket next to the alternatives. Amazon and eBay. Your full name, address, payment card, and purchase history sits in a centralized database. The seller gets your name and address. The carrier gets your card details. Third-party analytics track your browsing. Advertisers buy your purchase patterns. One breach exposes everything. And this model was built in the early 2000s. We just never questioned it. Web3 marketplaces like OpenSea, your wallet address is a pseudonym, but it's a weak pseudonym. Every transaction is public. Your entire purchase history is visible on a block explorer. Anyone can see what you bought, when you bought it, and how much you paid. And for physical goods, well, OpenSea doesn't really handle physical goods, precisely because the delivery problem is unsolved without privacy. dMarket on midnight, these obfuscated IDs that are unlinkable across roles and instances, encrypted delivery addresses that only the selected carrier can reach, shielded coin payments, no credit card processors, no payment data, no purchase history linkage because each transaction uses different obfuscated identities, and third-party escrow that removes the need for a centralized trust authority. The gap is clear. Traditional marketplaces trade privacy for convenience. Web3 marketplaces trade privacy for transparency. dMarket demonstrates that you can have the marketplace functionality without sacrificing privacy. If you design the architecture around privacy-enhancing technology from the ground up. This project was built as a hackathon project, one developer for the Midnight Summit 2025 hackathon in London, and it implements obfuscated identities, asymmetric encryption, shielded escrow, and a 7-state lifecycle with dispute resolution. That's the kind of applications Midnight enables when you actually use its privacy primitive. Three parties who don't trust each other, obfuscated identities that are unlinkable, and encrypted delivery addresses that only one person can read, shielded coin escrow with game theoretic guarantees, and a 7-state lifecycle where every transaction is a CK proof. That's dMarket, privacy preserving commerce on midnight. And the patterns here, obfuscated multi-role identities, asymmetric encryption in witnesses, shielded coin treasury management, these aren't specific to marketplaces. They apply to any multi-party system where participants need privacy but the system needs accountability. If you want to see how all of this it's actually connected and coded, the compact contract, the witness functions, the API layer, the React frontend, the build session walks through the full dMarket architecture end to end. And if the identity obfuscation pattern reminded you of the CK identity system from the last deep dive, the same primitives, different applications applies here as well. We help teams build exactly this kind of infrastructure. Privacy preserving multi-party systems, escrow architectures, midnight dApps with real disclosure boundaries. Links to everything in the description, including how to work with us. See you in the next one.